Okay, good everyone. Today we are going to be looking at integration by parts, which is going to be a new video, and this integration by parts is one of the important problem in calculus, which is integration. And now we have something like, let me give an example. Let's say we have y equals to integral of x square exponential x dx. So this is an example, and we want to solve this kind of problem. So this is a critical example of integration by parts. Now, when we have a product like variables of x, or let's say functions of x here, and there's a kind of product here, there are two major ways you can not two, let's say three major ways you can solve this. One of the ways is using substitution method, using when you have a form of integral of f of x, f prime of x, and also integration by parts. So depending on the way the question looks, you know the kind of approach you want to use to solve it. A question can have a product like this, and then the approach you can easily use an approach of a substitution method instead of integration by part and the likes. I get it now. So like that. So looking at this problem here, so how do you confront a problem like this? First of all, in integration by part, we have what we call the formula for integration by part. First of all, is what integral. Sorry, we have integral of u dv equals to uv minus integral of v du. Now this is the formula for integration by parts, and you know that here we have u and we have dv. So technically, some people just say these are u and these are v. So what if this one comes first and this one comes first second? You say that exponentiality is your u and x squared is your dv. No, it's not done that way. So there's a rule we use in integration by parts to know which one is our u and which one is our dv. So that rule is very important for you to know. So when you have any kind of problem, it's not necessarily what is here is your u and what is here your dv. It can be what is here that will be your u and what is here will be your dv. I get it now. So it is very important for you to know this rule, and it is called Laet Laet rule. Laet rule. Laet rule is used to pick the value of your u accurately. I don't know. So now what does this light is just an acronym. This L here means log. It means log. This I means inverse trigonometry. This A means algebra. This T means trigonometry, and this E means exponential. I don't know. So we have algebra, we have trigonometry, exponential, we have inverse trigonometry, we also have logarithm. I don't know. So now if you have a problem like this x square is algebraic expression, and this exponential x here is exponential. So if you look at this, we see that algebra comes before exponential, a comes before e. That means that what your x square, which is your a, will take the value of your u. I get it now. Let's say we have a sine here, sine x, which is trigonometry. Still, x square, which is a, which is algebra, still comes before trigonometry, which is your sine x. Therefore, your u will be what? X square. I don't know. Let's say we have log x. Let's say we have log x. Let's say we have log x and we have x square. I don't know. Let me circle this. Let's say we have log x and we have x square. Definitely in this question, x square will be what? Will be your dv, and log x will be your u, because here, if you look at it, L comes before A. L comes before A. That means what? Your log here comes before your algebraic expression. That means your u will take the value of what? Your log. So your u here will be the log, and this will be your dv. But in this problem, our u here is what? X square, and our dv here is what? Exponential x. So this is the rule we use to solve problem on integration by parts. So we used to detect which one is your u and which one is your dv. So quickly, let's solve this problem. We have what? We have y equals to integral of what? x square exponential x dx. That means we already know that our u is what, x square, and our dv is exponential x. That means your du you'll be what, 2x, and your dv you'll be, sorry, my v rather, my v will be what, exponential x. What do I mean? This preparation of this one will give me du, preparation will give me 2x dx, and integration of this one, sorry about that. So we have this. So from here, from our formula, now how do we solve this problem? So we know that integral of this gives me v, integration of exponential x still give me exponential x. So how do we solve this problem? From our formula, we have integral of u dv equals to uv minus integral of v du. So from here, we can easily continue our problem. So from here, what is our u and what is our v? Our u and v. So this is our u and this is our v. So from here we have what, u is what, x square, and v is exponential x either minus integral of v is exponential x, and your du is what, 2x dx. So from here, what do we now do? Furthermore, this one as well can still be written as x square exponential x minus 2 integral of x exponential x either dx. From here, we know that our 2 can come out here, and we have x exponential x, which is the same thing I wrote here. So from here, you look at this, we still have another problem here. We are not done. If you look at this one looks like this one still looks like integration by part. So I will use integration by part to solve this problem again. That means from here I can see my u is what, x, and my dv is what, exponential x. We already established that from Laet rule. We know that this will be our u and this will be our dv, still the same. Well, now what will my du? My du will be what, 1, and my dv, sorry, my v rather, my v, which is integral of this, give me what, exponential x either now. So that's my v. So from here, how do we continue our problem? So from here, same thing, write this. You have what, x square exponential x minus u open bracket minus 2 open brackets. Now this is our integral that we want to use integration by part for. So for this one, what do we have? We have uv, no, uv, no, from the formula it is integral of u dv equals to uv minus integral of v du. So from the formula, we know that we are having what, uv, which is what, x exponential x, then minus integral of v, what is our v, exponential x du, and du here is what, is 1 dx, then. So we have this, you get it now. So from here, we have what, x square exponential x then minus 2 open brackets what, x exponential x then minus integral of exponential x, and what is the integral of exponential x, which we have here, dx. Integral of exponential x will still give me exponential x, I get it now, plus I can put plus inside the bracket or outside the bracket, whichever way I want it. I can put it inside the bracket, plus c then. So plus c, we have this, I get it now. So this is this here. So from here, if you look at it, we are almost done. So let's expand this further to make it simpler. From here we have what, so from here we have what do we have? From here we have equals to, we have x square then exponential x minus 2x exponential x then minus, open the bracket with this, minus 2 times it give me minus 2 times it give me plus 2 then exponential x minus 2 that give me minus 2c, something like this, I get it now, which is what, which is same thing as what, x square, this is 2c, x square exponential x minus 2 exponential 2x exponential x I there, so plus 2 plus 2 exponential x I there, and you have eventually you have a minus 2c is still a constant, which is, let's call it d. So minus 2c still give us a constant, which is what, d. So this is the solution we have at the end of the day. So now there's a short method we can use to solve this problem to make it easier. It is called the DI table. The DI table is another way we can use to solve this problem. So the DI table, what is the DI table saying? We are going to have a table like this, whereby we have this is the differentiation, let's say dx, this is the integration, and this is your di I there. So from here, from this table, how are we going to cope with this table here? So from this table, first of all, this is our problem here. Let me write our problem. Our problem is integral of what? Integral of x square, integral of x square I there, integral of x square exponential x is our problem, dx, right? So this is our problem, and we want to use the AI table to make it what, life easier for us. And we already know that this is our u and this is our dv, right? So from here, because of that, we can easily furthermore finish up our question right there now. So this is our u, so place it here, and this is our dv, so place it here right there now. So we are going to be differentiating this side, we are going to be integrating this side right there now. So let's differentiate this one. What do you have? 2x, and let's integrate this one. We have exponential x. Differentiate this one again, you have 2. Here you have exponential x. Differentiate this, you have 0. You have exponential x. Since you have gotten 0, we'll stop. I get it now. So from here, what do? We now put our sign. The first sign that is always here is always plus, like an alternating sign. Are you getting now? So the first sign will be plus, the second will be minus, the next one will be plus, the next one will be minus, like that, like that, like that. I get it now. So this is it here. So from here, what do? We have what? This is how we are going to get our final answer. You pick this like this. I get it now. And then like that, like that. So we'll pick this like this. This is an arrow. We'll join it to this one. I then now. We'll pick this negative, and this, and join to this. I get it now. I'll pick positive and this, and join to this. I did now. Pick this and join to whatever. Can you see what I did now? I picked this one here. I did plus x square and join to the one under. I get it now. I pick from negative here to this, and I join the one under. I get it now. I pick the plus next line. I join to the one under. I get it now. I pick the negative here on the same line. I join it with the one under, which will be exponential x. I get it now. So that is how the DI table works. So from here, we already know that our final answer now will be equals to sorry about that. Our final answer here will now be equals to, now, plus x square exponential x. You have x square, that's multiplication, plus times this will give me x square, x square times this will give me x square exponential x. I get it now. And what, minus times this will give me minus 2x exponential x, and this and this will give me, and also from here we have plus 2 exponential x, that's plus 2, sorry. So from here, what do we have? We have this. So from here we continue. We have plus 2 exponential x, and that is it. I get it now. So if you look at this, you have plus 2x exponential x, which is this, minus what, 2x exponential x, which is this, and plus 2 exponential x, which is this. And this is a short method, or a short way to solve that problem instead of going through a long rigor. So we are stopping here for today, and probably we will have a part 2 for this video to look at some other few other examples and fire from there. So probably I'll see you in the next video. Thank you.